Hello everybody. Frigid day out there. Looks horrible. Hope nobody went outside and hope everybody is trying to is being safe. Remember, school is closed tomorrow. Just PSA for you. And I'm talking a little bit quietly because my wife is asleep and my daughter's asleep and I might fall asleep too. So we'll see how this goes. These notes are going to go with pages 5 and 6 in your notes packet, or maybe 5 through 7 if I'm not mistaken. And the purpose of it is to find the integrals of trig functions, common trig functions that we know. So to start you off, we're going to go and do the integral for sine and cosine, and you should go and follow along. So the integral of sine of x, if you can't remember, is negative cosine of x plus a constant of integration, and the integral of cosine x, the antiderivative of cosine x, is going to be sine of x plus c. Now what we're going to be interested in is the antiderivative of tan x. And you don't have to write this down right now because we're going to write it down in a second. We're going to want to know the antiderivative of secant x, because why not? We're going to want to know the antiderivative of cotangent of x. And we should also know the antiderivative of cosecant x, my best friend. So again, we're going to try to do the derivations of all the trig integrals, and then we'll go ahead and apply them to some problems. I'm going to try to also finish this video in 15 minutes, so let's see how I do on that regard. So in this chart, go on and write down each of those 4 integrals. We got tan x here, secant x, cotangent x, and cosecant x. And we're going to derive a couple of them. And then we're going to have you derive a couple on your own. For these first two, tan x and secant x, I'm actually going to want you to go ahead and derive after I give you the trick to how to find the antiderivative. So if that's not clear, let me go ahead and start you off. There's nothing I can really do with the integral of tan x. So I'm going to rewrite tan x as sine x over cosine x. Now, the antiderivative of sine x over cosine x, I still don't really know what that is, but what I could do is do a u sub. And in my class, remember I told you guys that a u sub on the denominator should always take you a long way. So I'm going to do u equals cosine x, and du, the derivative of cosine, is negative sine x. And I'm going to go ahead and stop there, and I'm going to take you to the next part of secant x. And then once I show you how to set up for secant x, I'm going to ask you to fill in both boxes at the top, and then when we go to the next slide, you'll see the answer for tan x and secant x and see if you got the antiderivative of each. So for the antiderivative of secant x, this is going to be a little bit weirder. Again, I don't really know the antiderivative of secant x off the top of my head, so I have to rewrite secant x in a little bit of a way, and you're not going to like this. Or maybe you will. Let's do some magic. So secant x could be multiplied by secant x plus tan x. I mean, duh, everybody knows that, except not really. The first time I saw that, I was like, what is going on? Where did that even come from? But anyway, so we'll multiply by secant x plus tan x, top and bottom, and let's rewrite and see what happens here. So now we get the integral of, if I distribute this secant x to both parts, I get secant squared x plus secant x tan x. And the denominator is staying the same. And it looks like we're going to need to do a u sub, because just multiplying by that one little part actually helped me out quite a bit. I could do a u sub on the denominator, which means du is going to be equal to the derivative of secant x is secant x tan x. I got to pick up the pace, Mr. Lincoln. Plus the derivative of tan x is secant squared x. And all of this is dx. And I left you in a prime spot here, so I would ask that you pause the video and finish up the derivation of the integral of tan x, and finish up the antiderivative of secant x. And then if you're really feeling like you're going to go for it, go ahead and find the antiderivative of cotangent x and cosecant x, because they are found in the similar way. So please pause the video now, try this on your own, and when you're ready, please resume the video. Gosh, it is really cold out there. Am I still recording? Ooh, I am still recording. Oh, I should have a drink of root beer. Love root beer. Oh, I gotta shave. Okay, let's go ahead and keep going here. Alright, let's see if you got it. The antiderivative of tan x, if you did all the work, is going to be equal to negative natural log of absolute value of cosine x plus c. The way we got that is we did a u sub, we got negative sine x, we needed to compensate the integral with a negative 1 on the outside and a negative 1 on the inside. And negative 1 sine x was du, so that's why du is in the numerator, the u is in the denominator, and the antiderivative of 1 over u is ln absolute value of u. And the negative 1 just stays in front, so you get negative natural log absolute value of cosine x plus c. Here's the tricky part. Each time they do these problems, they may write them as natural log absolute value of secant x plus c. Because when you raise that cosine x to the negative 1 power, that's the same as the reciprocal, which is cosine x. For secant x, if you do a u sub, we saw that we get secant x tan x, so we can rewrite that integral as du over u. And again, natural log absolute value of u plus c, which is equal to natural log of secant x plus tan x plus c. Please raise your hand if you got it correct. I'm sure there's a few of you that actually raised your hand, and that's awesome. Please tell your teacher that you raised your hand, because that's funny. For the next ones, I want you to go ahead and try to derive these. And if you're already stuck and you're not sure, use the tricks that we had here. Just rewrite cotangent of x as cosine x over sine x, cosecant x as cosecant x plus cotangent x, cosecant x plus cotangent x, and top and bottom. Rewrite, do a u sub, see what happens for both of them. Please pause the video and try this on your own. Resume when you're ready. Alright, I hope you were able to try it, and I'm not going to explain these two because they're similar as the last ones. Your answer should be natural log absolute value of sine of x plus c. And, oh boy, this keeps going. And negative natural log absolute value of cosine x plus cotangent x plus c. Mr. Lake can go over here. The work is here, so if you need to pause the video to see what work that was, please do. And the work for the other one is right here. So now we're going to go and spend the next 6 minutes trying some problems. And we'll do that back and forth where you pause, etc. Only 1 through 4 and 7 through 9 are going to be done from notes, just to let you know. We'll start with number 1. So before I even start, I'm going to write down that the integral of tan x dx is equal to natural log absolute value of secant x plus c, or it's equal to negative natural log absolute value of cosine of x plus c. I'm also going to write down that the integral of secant x, because that's going to come up on this page, is equal to natural log absolute value of secant x plus tan x plus c. It would behoove you, my class, I know you'll laugh at that, it would be incumbent upon you to actually memorize those formulas, so you don't have to derive them each time. Number 1. Well, it sure looks like we have the antiderivative of tan x, but there's a little bit of a problem. We got that 4x in the way. So let's do u equals 4x. That means du is equal to 4 dx. I think Ms. Schwartz divides by 4 on both sides. We get 1/4 du equals dx. So we're going to get the integral of tangent of, it looks like we're going to have a u, and where the dx was, we're going to put a 1/4 du. So times 1/4 du. We can rewrite that as a 1/4 integral of tangent of u plus c. And the antiderivative of tan, is negative natural log cosine, or natural log absolute value of secant. So we can keep going as equals 1/4 integral of, no more integral because we already found the antiderivative. So 1/4 natural log absolute value of secant of 4x plus c, or equals 1/4 ln, but a negative in front, absolute value of cosine of 4x plus c. And those are your answers. And I'm sorry I didn't include that negative there. Alright, for the next one, secant of 2x. Same thing. Let's do a u sub. So let's do a u equals 2x. du equals 2dx. I don't have a 2 in this, so I'm going to take a 2 in the front here, but I'm also going to divide by 1/2. So I have a 2 in the front, and I'm going to divide by 1/2. And I'm sorry that I was taking that somewhere. So now we're going to rewrite this as 1/2 integral of secant of u du. And the formula that we just had, hopefully you wrote it on the top of your paper. If you didn't, pause the video to do so. We're going to have 1/2 natural log of absolute value of secant of u plus tangent of u plus c. Make sure you close that absolute value. And in fact, we could do one better all in one shot because we know what u is. U is 2x. So we can actually put a 2x here. So secant of 2x plus tangent of 2x. And hopefully you're keeping up with this. You'll also notice that I skipped that u part in this from the number 1. Same idea though. If you know what your u is right off the bat, you're welcome to plug it in right off the bat. And that's your answer. For number 3. Oh, that one we don't have any problem with, because we can actually rewrite this as the integral of 3 sine x. And by the way, this is an optional step. Minus the integral of 2 cosine x dx. And thankfully, there's no u sub here. So we get equals negative 3 cosine x minus 2 sine of x plus c. For reasons that were listed at the very beginning, antiderivative of sine is negative cosine, antiderivative of cosine is of sine, and there's a negative in front already. No u subs necessary here. Okay, number 4 looks a little bit different. I'm going to ask you to pause the video and try this now. So go ahead and pause the video and try it now, please. So I hope you realize that sine cubed x is sine of x cubed times cosine x, which means you want to do a u sub on the composite part, which is sine. So when you do a u sub on the composite part, you are able to rewrite that original integral in a little bit simpler way, which is equal to u to the 4th over 4, or 1/4 u to the 4th, plus c, which is equal to 1/4 u is sine, so 1/4 sine to the 4th of x plus c. Please raise your hand if you got that right. Good job, guys. Really, really proud of you. Great class. Let's go to the next one. Great classes. So 7, 8, and 9 are the last ones that we're going to do. I'm going to ask you to pause the video and try these on your own now. Please pause the video now. Okay, so for number 7, I hope you got this. Hopefully you realize u is equal to x cubed minus 7, which du is equal to 3x squared dx. When you rewrite, you're going to get tan of u du. And the antiderivative of tan is negative natural log cosine of u. So you get negative natural log cosine of x cubed minus 7 plus c. Hopefully you got that one right. Number 8, similar idea with the u equals x to the 6. Same exact process. I just rewrote my answer here with natural log absolute value of secant, getting us used to that there's 2 possible ways to do secant or cosine with tan, with an antiderivative of tan. And for number 9, we're going to go over a tiny bit on the 15 minutes. So number 9, hopefully, again, you did your u is equal to x to the fourth plus 7. So du is equal to 4x cubed dx, and you end up getting a 7/4 antiderivative of 4x cubed. The whole point of this 4 is to make sure that we include the 4 for du. And really, you want to end up with a, here, with your u sub, so 7/4 antiderivative cotangent of u. And since we already derived the antiderivative cotangent, we want to just jump right to it, which is the natural log absolute value of sine of u. You are not expected to actually derive cotangent each time, which means our final answer is going to be equal to the 7/4 natural log of absolute value of sine of x to the fourth plus 7 plus c, or just to keep you on your toes, we could do the reciprocal of sine, which is cosecant, and that would just mean a negative in front of the log. Thanks for watching, guys, and good luck studying for that quiz on Friday. Stay warm out there.